Hi mathematicians! Today's video is about our notes to our future forgetful selves about identifying properties of rigid transformations. Well, actually the figures that result from those rigid transformations. And this is a case where it's really important to recognize what we already know about this topic from the previous lesson. So recall from our previous lesson that rigid transformations change a figure's location or its orientation. Remember, that's just the big kid word for what direction it's facing. But here's the most important thing for this lesson. It does not change its size. So let's see an example of how this helps us. So again, that big idea that centers around the fact that the size doesn't change when something's translated means if you know the measurements of the pre-image, you can determine the measurements of the image. Or if you know the measurements of the image, you can go back and figure out what the measurements were of the pre-image. It works both ways. So let's see how that would work in this example. So it doesn't matter which transformation you do. In this case, we happen to be dealing with a translation, but this method works no matter what the transformation is. So it still works with a rotation or a reflection. So if I'm looking in my diagram, if I know that in the pre-image, and I know the pre-image is this one because it doesn't have the little tick mark, right? So if A was 80 degrees, well then I know that the measurement for the angle in A prime, I'm going to draw a little arrow there because with my bad handwriting, I don't think I'm going to be able to squeeze 80 in there. I know that that angle is also 80 degrees. I'm going to try to make that a little neater. Not sure if I succeeded or failed, but I think it looks a little bit better to me. Because again, even though the shape was translated, the shape, the size, none of that changed. So by that same logic, if I know that angle C prime is 26 degrees, then I know as well that the measurement of the pre-image, angle C, is also 26 degrees as well. And so it doesn't give me the measure for either B or B prime, but remember from 7th grade that all triangles have 180 degrees total within all of their angle measurements. So I didn't say that very well. If you add all the angles together inside of a triangle, they add up to 180 degrees. So what I can do to figure out the measure of that third angle is I can take 180. I'm going to switch to a text box because I think that'll be a little bit neater for you guys. And I can subtract out the other two angles. So I can subtract out 80, and then I can subtract out the 26, and I know that that leaves me with the measure of the third angle, which is 74. So I can use that reasoning to figure out that angle B is 74 degrees. Draw a little arrow there, which also means that B prime is also 74 degrees. And then guess what? We can use exactly that same logic for the sides. So if I know that side AB here is 2, then I know that, AB prime, I should say, then I know that side AB has a length of 2. We're going to kind of ignore the fact that they didn't give us any units. And then if I know that on my pre-image, if I know that BC is 5, then I also know that BC prime has a length of 5. And then finally, let's say that they told us that in our pre-image, AC has a length of 6. That means that in the image, AC prime is also going to be 6. So as long as you know the measurements of either the pre-image or the image, you can find the measurements of the other figure.